Hello students, how are you all? I hope you all are doing good. Welcome to the Torque Institute. I am Anu Gupta, your physics faculty, who is going to teach you about the total internal reflection. Yes, today's topic is total internal reflection. Have you ever heard about it? No? So let's see what is TIR. Okay, and after that, we will also see its applications. Yes, we are going to see that what are the applications of TIR and how we can see these things in the daily life, what are its uses. Okay, and then we will be talking about the numericals. It's very important in the physics. After understanding any topic, we should know how to deal with the numericals. All right, so are you ready for this? Let's start the TIR. So before understanding total internal reflection, we are going to revise two terms. The first term is the reflection of light. Do you remember what is reflection of light? Yes. So whenever the light falls on any surface, then it bounces back, right? When we know that this is the incident light. Okay, this is the incident light, and when it strikes on this surface, it will reflect back like this. This is something called the reflection of light, and reflection occurs in the same medium. Like if I'm saying this is the air, in the air itself we have the incident ray, reflected ray, and normal. And in fact, if we are talking about its laws, we have the two laws: incident ray, reflected ray, and normal all lie on the same plane. Apart from that, the second law is there, which says that angle of incidence is always equals to angle of reflection, right? Okay, have you ever seen the reflection of light in the daily life? Can you give some examples? So yes, we have seen the reflection of light in daily life. Whenever the light falls on any surface like the plane mirror, right, then it reflects back the light. Yes, so this is something is called the reflection. Now the second term which we need to understand before TIR is the refraction of light. So what is refraction of light? In the refraction of light, what happens? The light moves from one medium to the other medium. Like light can move from air to water, like in this case, water to glass, glass to oil, like that. Means light has to move from one medium to the other medium. Then we have noticed that when the light moves from one medium to the other medium, it does not go straight, right? It bends, whether it bends towards the normal or away from the normal, depending upon the situation. Can you tell me those conditions? Come on, tell me. If the light moves from rarer medium to denser medium, then it bend towards the normal. Very good. And when the light moves from denser to rarer medium, then it moves away from the normal, right? So have you seen the reflection of light in the daily life? Can you give me some examples for that? So yes, we have observed that when we fall the light like this on this glass, then rather than going the light straight, it refracts, it bends, right? So here I can see that we have the refraction. Apart from that, you can see here we are not able to see the pencil straight. Here in the pencil, we can see that it feels like it's broken, right? But in reality, it is not, right? If we are talking about the floor of the swimming pool, then also we can say that the depth of the swimming pool we feel is less, but in reality it is more. So all these things, apart from this, you must have heard about the atmospheric refraction as well. Like we can take the example of the twinkling of stars. Yes, so here we talked about the refraction of light. So after understanding reflection of light and refraction of light, now we can move to the total internal reflection. Now you will be able to understand it in a better way. So let's see. So now we are going to consider that here we have the interface. Okay, and here we can see that here we have the medium. Let us suppose this one is the rarer medium and this one is the denser medium. Okay, so first of all we need to do this consideration. Now let us suppose this one is what? This one is water. I'm just taking the example. You can take anything which is denser, like this. Okay. Now let us consider that we have the object here at this point. Okay. Now we will see the light coming from it. So we need to understand one thing. Whenever we have the object, it gives the light in each and every direction, right? If I want to draw the light rays coming from this, then it is going in each and every direction. So we have the infinite rays coming from that. But we will just going to talk about those rays which are going in upward direction, okay? And very few rays we will be talking about, okay? Let's see this. So here I have this object. First of all, I'm talking about the ray which is coming like this. Okay, so I can say that we can observe here, if the incident ray is coming like this, it is coming on the surface, then we know that this ray will go straight like this. Okay, this is the incident ray, this is the refracted ray, no bending towards the normal, no bending away from the normal. Okay, now let's consider the another one. If I am considering the other ray which is falling like this, and if I have to draw the normal, then I can draw the normal something like this, right? So I can see here that the ray is going like this. So this is the incident ray. Let us suppose this is the angle of incidence I1. Then what do you know? If the ray is moving from denser medium to rarer medium, then it should bend what? Away from the normal. Yes, very good. Like let us suppose if there is no medium change, then this ray will go like this, right? But what we are saying, it will go away from the normal now. So that means here we have the normal, so it should go like this. So this is the refracted ray. Understood? Now, let us suppose if I am going to take the other ray, which is far from here. So I will take like this. This is the normal which I will going to draw. See? Like this, right? So what do I know? If I'm talking about this particular angle of incidence, is this greater than or less than this? So I can say this angle of incidence is greater than this angle. So if angle of incidence is greater, then accordingly I can say that now this ray will bend away from the normal, and that too like this, right? So this is my ray. Okay, it is bending like this. Now I am going to take the another one ray. So if another ray is something like this, so I am finding that this angle is greater than the previous angle. Okay, so I can say I3 is greater than I2. Now I found that whenever the light is falling, the refracted ray is bending like this. Now I am on that particular condition and that particular situation when I'm finding that refracted ray is going like this. See, it is going like this. Okay, so here I can say that this is the refracted ray. So angle of refraction is 90 degree here. Okay, what I'm saying, angle of refraction is 90 degree. So if you find that particular angle of incidence, that particular angle of incidence at which angle of refraction is 90 degree. Are you listening this thing? I'm talking about that angle of incidence at which angle of refraction is equals to 90 degree. I call this angle of incidence as critical angle. This is called the critical angle. Got it? So first of all, we need to understand this term. Now let's move further. After that, if I'm going to take one more ray, which is like this. So definitely the angle of incidence which I'll be talking about, that must be greater than the critical angle. Here, this is the critical angle, right? I3 is basically the critical angle, right? So this must be greater than critical angle. So we found this thing when the ray is greater than, when the incident ray is greater than critical angle, then finally what will happen? Refracted ray bended like this. Now what will happen? It has to come like this. It will come here like this. So what we have observed, that finally there will be the situation when the light will completely reflect back in the same medium, right? So what is TIR? Total internal reflection. That means the light will going to reflect back into the same medium. Okay, that the light will going to reflect back into the same medium. But you must have observed that in every case it is not happening, right? What happened here? When the light is moving from denser to rarer medium. So first of all, there is a condition. The first condition is that the light has to move from denser to rarer. Okay, it cannot happen in rarer to denser. It has to move from denser to rarer, only then it is possible, first of all. The second condition is that the angle of incidence, see this angle of incidence should be greater than critical angle. Only in that case it is possible. Okay, so we have the two required conditions to occur the total internal reflection. So is it clear? Once more I am going to repeat it for you, that if we have the object at this point, then we have the number of rays which are coming from this. So if I'm talking about this ray, this will go straight. If I'm talking about this ray, it will bend like this. If I'm talking about this, in which angle of incidence is greater than this angle, the ray will bend like this. In the other one, this will be the reflected ray, and finally, refracted ray I mean, and finally the ray will reflect back. And you found that the reflection is 100%, no loss of energy, no loss of energy. So this is something is what, that is TIR. That's how we can draw it. So whenever in the exam you need to write the definition for the TR, that's how you have to write. Okay, what is that definition? When light travels from a denser medium to a rarer medium, even the condition is also given here. When the light travels from a denser medium to a rarer medium and its incident angle more than the critical angle, it has to be like this only. It is completely reflected back in the denser medium. This complete inward return of the light is known as TIR, which you can see here. The light is falling like this, it will go like this. So this is the refracted light. In this one, we can see that when the light is falling like this, angle of refraction is 90. So this particular angle is critical angle. That angle of incidence is called critical angle. And the third one, when the angle of incidence is greater than critical angle, then the light will reflect back like this. So you understood this? In the exam, if they will ask you the critical angle definition, that's how you can write. Okay? Is it clear? All right. So after understanding this, I would like to tell you something about its derivation also, like its formula also. Like if someone will ask you the formula of critical angle, then how will we find? So let's talk about this. Okay. So let us suppose here, if this is the incident ray and this is the refracted ray, I'm going to talk about that condition when angle of incidence is equal to critical angle, then angle of refraction is 90 degree, right? Let us suppose the refractive index here is mu2 and the refractive index is mu1. I hope you remember refractive index, right? So now I'm going to apply the Snell's law here. Check. Let's apply Snell's law. According to the Snell's law, mu into sine I equals to constant, right? So I can see here that this is the refractive index and this is the angle. So we can write like this, mu2 into sine of IC equals to mu1 into sine 90, right? Now mu2 into sine IC equals to mu1, sine 90 is equals to 1. So this can be written like this, mu2 by mu1 equals to 1 upon sine of IC, right? Which can be written like this also, mu2 1, that means refractive index of 2 with respect to 1 is equals to 1 by sine IC. Now you need to remember this formula, okay, this formula for the critical angle, Okay, so I can say that refractive index is inversely proportional to critical angle. At the upper side, we have written the denser medium refractive index. Understood? Okay, so here we understood the theory of the TIR, and apart from that, we saw the formula also. Okay, now it is the time to find out, to see the applications of the TIR. Yes, where the TIR occurs in our daily life. So let's come here. So this is what? This is the mirage. Have you ever heard about it? Mirage formation. Yes. So see how in the mirage TIR is doing the work. Let's see here. So what we have to do in this, we are saying that we are talking about the desert area. In the desert area, what happens? This particular regions become very hot, and that's why this section becomes rarer medium, and the upper one is denser, and the other one is again denser, like this. So here we have the rarer, then denser, 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 denser. So in the TIR, what is the condition? That the ray should move from denser to rarer medium, right? It should move from denser to rarer. So if I'll take the example of this tree, let us suppose the light is coming from that. Now what do we know? Here we have the few layers like this. Okay. So when it is moving from this to this, it will bend away from the normal, again away from the normal, again away from the normal. So every time what is happening, angle of incidence is increasing. And finally, you will find that there will be a one point when the angle of incidence will be greater than critical angle. Your understanding point? That first of all, the condition should be, it should move from denser to rarer medium, which is happening. It is moving from denser to rarer medium. Now, the second condition says that angle of incidence should be greater than critical angle. So, at the point when the angle of incidence will become greater than critical angle, then the light will reflect back. Yes, you're right. And the light will reflect back straight like this. Now, the person will feel that the light is coming something from here. So, the object is here. Actually, the object is here, but the image is appearing here. Why? It is because of the TIR. It's because of the total internal reflection which is happening here. You understood? So, now you are remembering that you must have seen the mirage. Okay? In the summer also you have seen this. In the desert area, you must have experienced this mirage formation. Right? Next, let's talk about the optical fibers. Have you heard about it? Optical fibers. So optical fibers are very thin fibers which can be made up of the glass or the plastic. But the interesting thing is that optical fibers are used for the communication purpose. Yes, if you want that, you will get the high accuracy data, and apart from that, you want that there will be no loss of energy. Then we will prefer the optical fibers, because optical fibers works on TIR. And we already talked about this thing, that in optical fibers and in TIR there is no loss. 100% of the light reflects back, and that's why you get the maximum output, right? Now let's see how optical fibers work. So you will observe that optical fibers are something like this. They are very thin fibers made up of glass or plastic. So something like this you will find in fibers. Actually, there are the two coatings. This one is something called core, and this something is called cladding. Here you have cladding, here you have cladding, and in between the cladding you have some portion that's core. Okay. Now we are saying that in the core you find this one is what? Denser medium. Okay, this one is denser, and this section is rarer. Rarer. So it is something like this. Okay. Now, what happens? When we fall the light here, okay, so what do we know? This is what? This is denser medium, this one is rarer. So the light is moving from denser to rarer medium. Now we fall the light in such a way that this particular angle is greater than the critical angle. Okay, Then in this case, what will happen? The light will reflect back like this, then again, then again, and then again. So that's how it can transfer the information from one point to the other point without having the loss of the signal. You got this? So these are the optical fibers in real life. They look like this, very thin structure they have. Okay, so these are some applications of the TIR in the daily life. Now it's time for the numericals. Now let's see how the numericals can be asked on this. So first of all, they are saying that a light wave travels from glass to water. So if it is from glass to water means denser to rarer. So first condition is satisfied. Then refractive index for glass and water are given like this. They are asking for the value of the critical angle. Let's see. Glass is 3/2 and water is 4/3. Right? Like this. So if they are saying the light is moving from glass to water like this, so I can say this is mu g, this is mu w, and the light is going like this, right? So, but we have to talk about the critical angle, so it's better to take like this. So now we will say that as we know, mu is what? 1 upon sine I c, and that too we know that is mu 2 by mu 1. If you remember that, then you must remember that mu 2 is the refractive index of the denser medium. So here we have the denser medium is glass. So mu g by mu w is 1 upon sine IC. Yes. Now mu g is what? 3/2. Mu w is 4/3. Right? So how we can solve this? 3 will go to this side and 4 will go here. So this will be 9/8 equals to 1 upon sine IC. So I can say we can take the reciprocal of this. So sine IC is equals to 8/9. Let's see the options. Do we have these options? Okay, so here we can say that we have the options in sine inverse form. So let's convert this. So this can be written as IC equals to sine inverse of 8/9, because if it will go to that side, it will become an inverse. So what's the correct answer? Yes, option C is the correct answer for this question. So you understood this? How we have to solve the numericals on the TIR? We just need to remember the formula mu equals to 1 by sine IC. Right? Okay. So now let's summarize whatever we have discussed in today's lecture. First of all, we have talked about that what is TIR and what are its conditions. Conditions are what? The ray should move from denser to rarer medium, and the second condition is that the angle of incidence should be greater than critical angle. Only in that case TIR occurs. Means the light will completely reflect back into the same medium. Okay. We also talked about the critical angle. That critical angle is that angle of incidence at which angle of refraction becomes 90 degree, right? And we have the formula for sine IC, which is equals to 1 by mu. So I hope you understood all the points which we have discussed in today's lecture, and must try the questions from the TIR and do study hard. So thank you everyone to watch this lecture. We'll meet soon again. Thank you everyone. Take care.